Welcome back. It's a week later since the last video, and we're going to pick up right where we left off. And if you guys have a little bit of a recollection, we were talking about this slide, and then as we finished up last time, we actually landed on this slide before we called it a day. But the whole point is, with this, is that concept of the entity and its attributes, so like what belongs to a certain entity becomes an important thing. And I don't want to mire you in terminology. I don't want you to freak out on the words of it. But if you start to think about the words in a logical sense, I think that helps a little bit in what it actually means. So in this case, just to kind of reiterate where we left off, we are talking about some sort of an employee, right? So if you think of yourself as an employee for a company, you know you have certain attributes, and that's kind of the point here. So this is an example of a data model where the entity has all of its attributes, and the dark blue part of it is what? The unique identifier, right? And terminology-wise, this is what we would probably call our primary key for this table. Primary keys help us to both index the table and to make sure that the contents are unique. Remember, we talked about all the different ways that people can have the same name, same birthday, and my name doesn't fall in that category, but it's not unusual for some people to have very, very similar names, you know? Especially, you know, if you're like falling into certain like religious categories. So if you think of yourself as like a Christian, how many like Mark, Mikes, Luke's, John's, you know, et cetera, because you're Catholic, right? And then your middle name is probably one of those variants too, and then you probably have some really common names. So it's not really that unusual. The next thing that they show here is in the second box, B, is where you only have the identifier. So we don't have anything showing any of the attributes of the employee, just the ID number. So like just think of like when you're logging into something, right? Maybe you have to use your ID number. For some systems here, we have to do that. Students tend to do that more than employees do. And then you can look at the employee with no attributes. I don't know what good that would do, but you can still conceptualize it, though. That's really kind of the point. All right. The thing that's kind of interesting here is it says entities can be associated with one another in two different ways. So one says relationship classes, so associations among entity classes. So in other words, you have many different things that you can belong to, is the way that I read that. Or relationship instances, where there's many instances of that particular entity participating in certain activities. So for example, as an employee, I would love to have my name on the pay table. You know, I got paid, right? So many times you would have many instances there. See the difference? All right. There's also what we call the degree of the relationship between things in the database. So in many cases, we have what we call a simple binary relationship, right? Where it's kind of a one-to-one type of thing. Or you might find that you have a ternary relationship, which means more than two. So to see that in the graphic, they have this little chart here. So if they give this example. It says the employee has a skill, right? One employee, that skill belongs to this employee. Could the employee have other skills? Could. But relative to the one skill, that's a binary relationship. That skill, that employee. With this ternary relationship, then you start pulling in multiple entities that connect to it. It doesn't have to be just three. But I will tell you that it gets to this point where logically it becomes very difficult to make many connections to one singular concept. But this is kind of a nice little graphic that explains that difference when you think of it in that way. All right. Next thing. It says the principal difference between an entity and a table relation is that you can express a relationship between entities without using foreign keys. So we really haven't talked a lot about primary and foreign key, but let's suffice it to say this, and I put this in the course shell, and I just basically quickly Wikipedia it, and grabbed the definition and threw it into our course shell, which is this. It says, a primary key uniquely identifies a record in the in the relational database table. So if we have an employee table, you'll have an employee ID, and that ID number has to be unique. Nobody else can have it, right? A foreign key is one that points to a key in a table, but it's actually a primary key in a different table that we pull in. So for example, as an employee, I want to be listed in that pay table, right? So like my pay stubs. And they'll probably have my ID number to link me, and that ID number is a foreign key because it's a primary key in another table, and it connects to this table as a foreign key. So it can't exist here. In other words, they're not going to pay somebody that isn't a valid employee, right? So that number's got to be valid. The way that we make sure that it's valid is by making it a foreign key. It's a primary key over here. It's not over here, but because it's the primary key here, we can make it a foreign key here to ensure the validity of the information. We know the information's real. See that connection? All right. And it says, this makes it easier to work with the entities in the early design process where the very existence of entities in relationship is uncertain, and that's very true. So as you start to build a database from scratch, which is kind of where we're going here, it becomes really important to start to identify those pieces of information that you can latch onto as either being a key field of one sort, primary or foreign, so you understand that it's a valid, significant piece of information. That's, I think, something that you learn as you go. You can't just kind of ad hoc throw stuff in. It has to make sense. All right. Let's talk about some more of these words here. Cardinality. Have you guys ever heard that word? Right? And basically, as it says in that first bullet there, it basically just means a count. So we're looking at the count. So when I had you do that count little thing that you did, that was to figure out how many records are in the table. How many are we actually dealing with? Now, there's this concept of maximum and minimum, and I want you to look at those highlighted words there. It said, maximum cardinality is the maximum number of relationship instances in which an entity can participate. So for example, if I'm the employee, if I get fired, I'm not going to participate in the pay table a whole lot. But if I keep my job, I can participate in that table many times, hopefully, every couple weeks or however often you get paid. There's also a minimum, and I'm not sure my example is really resonating that well, but it says the minimum number of relationship instances in which an entity must participate. So for example, if you have a table that stores your address, chances are you're not going to have more than one address. Although I've known people that have had, think, like if you're a snowbird, say Florida, Wisconsin kind of thing, I've known people that have been in that category. So chances are if you ask somebody for their phone number, you probably only think that you need to have one spot for a phone number in a database table, right? Not anymore, right? Home phone, mobile phone, work mobile phone, right? Vacation home, Google Voice number, et cetera, et cetera. So that's an example of one that's kind of grown, and it doesn't have to be a minimum. But we think about those minimum and maximums. Let's talk about some of this really important terminology here. And for me, some of these concepts, I think, get to the point where they're probably some of the more critical ones that you learn in terms of how the information is organized. So it says maximum cardinality is the maximum number of relationship instances in which an entity can participate. So we need to define those in some cases. So for example, if you hire somebody and you give them an employee ID number in the employee table, and then you give them a job or a title, for example, they can only have one title. Well, maybe. Yeah, right. It depends on where you work. But in most circumstances, you would think that one person has one job or one title. And in that case, we would call that a one-to-one relationship. If you happen to be, like I'm in the situation where I can say that I'm an instructor of web software, I'm an instructor of data analytics, and I'm the chair of the IT department. So I might actually fit in the second category for my job titles because there's one of me and I have actually several different positions. Now granted, they're all kind of the same thing. Not exactly, the chair thing is a little different, but that's the concept there. So, or a different way to think of it, my one employee, many paychecks, right? And it can't go the other way around. I can't have one paycheck for many employees, that doesn't work. So that's an important concept. You also have the situation where you'll go many to many. Now I'm trying to think of an example of that one. Get somebody to think of an example. What would be an example where one person, one entity, see here's where the terminology comes in, because a person is a great example of an entity.
Like a class to subject,
Ah, very clever, Vaughn. Right, I think that's a really good example. So I could look at you guys as a collective, where you guys are a collected grouping of entities, where this group of entities can have many grades, for example, or many tuition bills. Hopefully not too many tuition bills. But in some cases, you'll find many to many. So for example, if we use that like snowbird example, right? Like if you do happen to have more than one address, then chances are you probably also have multiple phone numbers. So it wouldn't be unusual for each location you might have multiple phone numbers. So that would be a many to many type of example. All right. Now, when we start to do our diagramming, and this is where I think it gets a little bit interesting. They here are still working with conception. Okay, so they're showing some examples of these types of relationships. So a one-to-one. Okay, I think that's a really good example. So each one of us employees has one like ID or badge, right? So we have to use that to log into the printers, for example. Don't tell anybody I have more than one, because I lose them and I find them again. But it's the same badge, right? It's the same picture, it's the same number on the badge, but okay, one-to-one. And could an employee have more than one computer? Sure, that's what they're putting in here. So one-to-many. And you see the notation that they're using. And then we can also have an employee to skills. So we can have many employees with the same skill, or many skills with many different employees that can do them, and it kind of goes both directions. Now how you arrange that is going to dictate how the data is structured and formed. All right. I'm not worried about a lot of this terminology, not too excessively, but I want you guys to be able to read through it and grab onto it. But the whole point here is this concept of parent and child, which I hope that you already understand a little bit from programming, and where a child is part of the parent or it comes from the parent. And then what they're indicating here is some of the terminology that a lot of people use in the field, and we call it a has-a relationship. So in other words, an employee has one or more computers. That's possible, for sure. A computer has one assigned employee, right? So the laptop that I'm using to record this is assigned to me. Nobody else is it assigned to, just to me, right? And you guys already know I have more than one computer. Usually I carry them both or more with me. That's not the case today. I'm traveling light today. Sometimes that's not the case. All right. Where were we? ParentChild. let's talk about the minimum. So once again, they repeat the definition. It says minimum cardinality is the minimum number of entity instances that must participate in a relationship. So I want you to think about that wording really carefully, because you can read it and just have it go in one ear, out the other, and not understand a darn thing about it. So it says minimums are generally stated as either 0 or 1. So if 0, then participation in the relationship by the entity is optional. And no entity instance must participate in the relationship. So let me give you an example. Maybe they would ask me to come in and teach on Saturday. You know what? I'm not required to, so I wouldn't. So you can mark that one down as a 0. I try my hardest not to come in on a Saturday. There has been some training I had to do for, well, actually, there's one day a year I have to come in on a Saturday, 2 days a year. Okay, darn it. All right. Those are for adjunct in-services, if you're curious. If 1, then participation in the relationship by the entity is mandatory, and at least one entity instance must participate. So let's say that we all have to have an employee ID number. We must. Otherwise, you know what? You're not getting your paycheck. Okay? That's a good example, really. No employee ID, no paycheck. You can bet that person's going to get an ID, right? As soon as they want to pay the rent. All right, so they're going to show us a couple examples of the minimum cardinality coming up here. If you see a circle, then the entity is optional. So they're going to show you this slide coming up. And I want you to take a really careful look at these. And maybe you've seen these before if you've done databases where they put in the slash or the circle. And you notice the circle means what? Optional. It's not forced, right? It's an optional relationship where with the badge, you know, every employee must have a badge, so there's a slash on both sides. You know, who says that an employee has to have a computer assigned to them? Nothing, right? Maybe you're in a situation, maybe you use a computer, but it's not assigned to you. You just walk up, log in, do your thing, log out, and you're done. And then you have here optional to mandatory. So every employee, well, we need somebody with that skill, right? That's mandatory. But you don't necessarily have to be the person with it. But somebody hopefully has that skill. All right. And I'm hoping that that starts to make a little bit more sense. As we start to move through some of the diagramming here, you're going to catch on some really important concepts, because we're going to be looking at that assignment where it's basically, what is it, like a parking ticket or citation or something like that. There's a bunch of information embedded on it, and it implies certain things. And then we kind of have to logic through what it implies and then make a notation with some of this notation to get it right. Okay. So let's take a look at this. So here we have a department. So the circle indicates optional and mandatory. So what does 1-N or 1:N mean? One to many, correct. So there's one department and many employees. Now the question...
I'm sorry, what's the difference between the N and the F?
You know, that's a really great question, because I always learned it with an M myself. And I think that just what they chose to do. Or unless it's a new convention that's new to me. And you know, given my age, probably. So.
Is it just so they don't have an N tag and use the same thing?
That's part of it, because if you're going to do many to many, you notice that they don't want 2 M's. I don't know what difference that really makes. In the old days, and I think of like Access in particular, and Fox Pro did the same thing, you get a little infinity sign in either end for the manys. That's how it's designated. It's just a syntax that they're pointing out here. But they come up with some sort of a thing. Some of these notations, though, are fairly standard ones. And so let's take a look at the comparison between the minimum and the maximum cardinality here. So here, the minimum says optional to many. Because the department is optional, but you might have many employees. Otherwise, when it's required, and then I want you to look at the notation on the far side here with what we call a little crow's foot. That's what they call it, that symbol. And it's supposed to indicate that it's a required one-to-many relationship is what that means. Like I said, I'm not worried so much about the language of how we say these things as long as you understand why we're doing it and does it make sense to do it. And how do you know if it makes sense? The situation will dictate. Because it doesn't make sense, for example, for the same employee to collect multiple checks for the same week of pay. It does not make sense. Maybe for the employee it does, but not for the company. All right. Now take a look at the chart here. So if you're going to have the slashes on both ends, we're implying one-to-one, exactly one, and it's required, right? The second one says that it's mandatory and there's many different possibilities. So let's hope that's like my paycheck, right? There's one of me and that paycheck is mandatory. On the optional ones, we're going optional one-to-one. And notice that it's like 0 or 1 because it's optional. You don't have to do it. Okay? And optional for many. And I think that once you get that syntax, that will help you quite a bit. Give you the example here, and notice it says an original entity relationship model version where we have the employee is optional and the skill is mandatory, and notice it's a many-to-many. And yeah, I don't like that notation. I really don't, but that's what they're using here. Then here we're showing the optional to mandatory, right? And then many-to-many on either side. And notice how we're combining the two into one. And that's really kind of the point here, just to show you that terminology. So when we look at the homework, this is the kind of thing that we're going to try to figure out. Okay? So it's not to make it ridiculously difficult. And that's really as far as I'm going to take the presentation here. So the next sections are some of the sections that we're skipping in the readings, and then there's some stuff that we come back to at the end. But for right now, this really is enough for us to turn our attention to the homework. All right. I'm going to end this video here. And actually, I'm just going to go ahead and end this video here, and then I'll start a fresh one to do the homework.